Hello everyone. Like 10 years ago, the addition to the Linux kernel of namespaces and cgroups opened the way to containerization. Well, maybe you could argue that BSD jails and salary zones were there before, that's true, but for Linux, that basically started around 10 years ago. Fast forward 5 years later, Docker Inc. created the Docker daemon, the Docker engine that everybody knows and loves or hates, actually. And that really made containerization available to the mass. It really got a huge adoption when Docker introduced the concepts of Docker images, Docker registries, a fast way to build images and to distribute them. Meanwhile, the JVM also adapted to the containerization during 2013 and 2018. And when people started using containers, even in production, at that moment, they also needed some orchestration because usually an application is not just one process running, right? You need to orchestrate several of them. So containerization was also introduced very soon after with Docker Swarm from Docker Inc., as well as with Mesos and, of course, Kubernetes. So, how do you build Docker images in 2018? Do you build them the same way that you used to build them in 2013? How well does the JVM support containerization and restrictions such as cgroups? What about orchestration? What is Kubernetes? What is its architecture? And what are the most common objects that you would use with Kubernetes? How do you package Kubernetes deployments? As a Java developer, which tool would you use? Would you use exactly the same tool, or do you need something to cope with this extra complexity of containerization and then orchestration? Also, how do you integrate well with Kubernetes? Once you know how to deploy to Kubernetes, how can you integrate well with the Kubernetes ecosystem? Are there special tools that are common through all Kubernetes applications? Can you also extend Kubernetes to take your application to the next level? My name is Dahanne, and I will try to answer those questions during this 2-hour tutorial about Kubernetes for Java developers. I am a software engineer. I'm working for Software AG. It's a German company that is famous for enterprise software, such as Adabas, Apama, Universal Messaging, and Terracotta. I am working mainly on Terracotta products, so we have quite some open source offering, Cache Free, Terracotta Server, and soon Terracotta Store. During those last 2 years, I've been focusing some of my time on, well, I've been investing some of my time on trying to make our software work well with cloud deployments. So at first, I was really focused on trying to, just build correct Docker images for our software. And then, of course, I had to investigate orchestration as well. So this talk is really about my findings, what I found interesting, and what I think that the current trends and I hope the lasting trends are in 2018. Also, yeah, I'm also a Java developer, definitely, and I'm working on management and monitoring aspects. So this is why this is also a topic of interest to me in the cloud. When I'm not working for Software AG, sometimes I find the time to be a Montreal Java user group co-leader. And this same group is also in, we also spend some time with Devox for Kids Quebec, when, twice a year we run workshops for children to let them interact with robotics and, give them the taste of I don't know, programming somehow. Let's get started with the content. So, of course, I'll go back quickly on what are containers and how well the JVM is interacting with containers, because there was definitely some progress made on that regard. And also the interesting thing is that, as I told you, 5 years has passed since Docker Inc. since the Docker engine was introduced. And there are many contenders now to build Docker images, so we'll see about that. Then in the second chapter, we'll talk about Kubernetes 101, so I'll really go through the global architecture and what are the most common objects. Also, I will talk about Helm. Tools to become a 100x developer with Kubernetes. As I told you, added complexity means you also need some tools to cope with that. and finally integrating with Kubernetes, with, for example, monitoring with Prometheus, and also using the Java SDKs to create your custom resource definitions. So we'll see all about this. I gave the same session yesterday evening. It was just a 45 minutes bout of fever. So today, with 2 hours, I will take time for demos. And of course, if you want to interrupt me or ask me questions, I would be very glad to answer them. Feel free to ask anytime. So let's get started with the basics. Containers, what are those? Well, basically, you can create containers, whatever. When you have processes running on containers, they are basically, all the containers are sharing the same kernel, right? So of course, your host machine, so the machine that will be hosting all those containers, it can run on a VM or directly on bare metal. That's fine either way. The most important thing is that it must run a modern Linux kernel. You've heard me talk about Linux several times already because I'm going to be focusing on Linux containers. Yesterday evening, some people asked me about Windows containers. And yes, they exist. There are some native Windows containers, and you can actually run them with Docker for Windows or even Docker EE. But I don't have much experience with Windows containers. And as far as I could grab today, they are pretty large images. And I know Microsoft and Docker Inc. are working on trying to make them smaller and more convenient to use. And also about Kubernetes, I think it's working, but it's really beta, actually, for the moment. So if you're really getting into Kubernetes now, maybe you should first investigate Linux before moving to Windows containers, I think, at least for Kubernetes. So yeah, the kernel, very important, shared by all the containers. And what's available inside container? What does your process see and can do? Well, it only sees what we want it to see. So this is thanks to namespaces. So basically, all the processes inside your container. So usually you would just have one. Well, this is a good practice to have just one process per container. And this process would have its own host name, its own network, its own volumes, file system. And also, this process would be limited thanks to cgroups. So cgroups is the Linux feature that allows you to put constraints in terms of memory and CPU. Talking about cgroups, how well does the JVM handle cgroups? Well, first of all, let's go back to the global, to the historical way of the JVM guesses CPU and memory resources. By default, this is called, I think, Java ergonomics. So whenever the JVM starts up, it will try to find out what is the amount of memory that is available on the machine. So if you don't say anything, if you don't put any constraints to the JVM, it will try to guess it. And once it finds it, usually asking the host, it will divide it by 4 and say, all right, this is my max memory. And well, let's have a look at this. So here, for example, I'll be running Java in a Docker container. I'm using Docker for Mac. So obviously my Docker daemon is running inside a VM. So here I will print the flags from the JVM that will tell me how much memory it can use. So basically it's telling me that it can use around 500 megabytes, right? And if I look at my Docker daemon, I can see that I get 2 gigs available. So far, so good. The JVM guessed it right. But what about me setting some constraint, right? So if I do the same thing and then I put a memory constraint on it. So this constraint, here I'm limiting the container max memory to 512 megabytes. So normally the JVM should detect that and then divide it by 4. This is what I expected to happen. And this flag -m is basically setting cgroups constraint on memory. Unfortunately, the JVM didn't get that. It still thinks that it's 2 gigs divided by 4. It's because the JVM is not cgroups aware. If you look at the version of my JVM, it's a Java 8 build 181. Now, fast forward to the future, and if I go run exactly the same thing, but with Java 10, you'll see that it's much better. Java 10 was cgroups aware, and it understood that I set some limits on it. So then you would ask me, oh, wow, how can we run Java 8? Well, fortunately enough, some JVM flags exist. So thanks to those JVM flags, you can set them to your Java 8 container, well, to your Java 8 JVM. And normally, even with 8, that should work just fine this time. As you can see, Java 8 could be made cgroups aware thanks to those experimental flags. And it's really funny because I arrived at the conference with this knowledge, you know. And yesterday, there was a talk actually specifically about the JVM and cgroups constraint. And there was someone from Oracle, I'm sorry, I don't remember his name, but he raised his hand and he said, no, this is no longer the case, because the cgroups awareness of the Java 10 JVM was backported into Java 8. So from Java 8 191, actually, well, you can forget what you can actually forget the problem I'm talking about, because we fixed it, it's backported, so by default, the JVM will detect cgroups properly. So you don't have to worry about this anymore. Now, Java 8 update 191 was out 6 days ago, well, maybe 1 week ago, so there is no Docker image yet on Docker Hub, so this is why I cannot show it today. But yeah, normally in 2 weeks, that should be fixed. And if you're using the latest JVM, just stop worrying about those flags. If we go there, yeah, it was added in Java 10, and now, yeah, it has been backported to Java 8. I will also just, still on that topic, I would like also to bring, to show an example about this, is that, you know, it's all, I think it all sounds pretty rhetorical, but I will run an example of what happens when your JVM is running out of memory. And here, for example, this application, this small Java main class, will try to allocate some memory until it goes up to 70% of the max. So this application, if I run it with constraints, so here I'm giving it 300 megabytes constraint. And if I run it until the end, as you can see, there is killed. And what is interesting to me here is the kill signal that was sent. If you look at the kill signal, so as you can see, when the JVM started, it thought that it could use 500 megabytes, once again, because it was not cgroups aware. And it tried to allocate, but it soon found the limit, and it got killed by exited with this number. So I'm pretty sure that some of you here in this room have already seen this in some Jenkins build, you know, that are failing because 137 out of memory error. Yeah, that was an unexpected where the JVM thought it could still allocate some memory, but it ran out because of a container constraint. So normally, in the future, once again, you shouldn't see this anymore because the JVM is really handling cgroups properly now. So we're good. What about putting real-life application in containers? So let's take this example of this demo app. So it's basically a web application. It's based on jhipster, and jhipster is actually itself based on Spring Boot too. So when I am locally developing for this application, usually I would just run with an H2 memory database. So this application would run without any dependencies. So that should be pretty easy to use. As you can see, this application is actually a monolith. They still exist in 2018. So, and actually it's a proud monolith. So let's take this monolith web application in a container. So it's exposing apparently port 8080, so we'll do just that, with our container definition. Okay, so the thing that we would do probably is that whenever we want to, well, the first thing that we would need to do is we will build this application. Here I'm using Maven. I'm using a profile, a developer profile, because I don't want to have dependencies on MySQL, for example. And I'm also going to skip tests. It's just a demo, so that's fine. So the output of my build will probably be a jar or a war. And Spring Boot usually builds for you. Well, as you can see, there is the repackage phase, so it will build for me what we call a fat jar, right? So it's a jar that you start with java-jar, and then you're good to go. So basically, if you take this jar and you put it inside a container, you just need to call the JVM java-jar, and then it should be ready to go. So the good news is that I already created such a Docker file. Here, I'm saying from OpenJDK 8 GRE, because I don't need a JDK. It was already built on my machine. And I want to add this war to /app.war. I'm also going to use those Java OPTS that are still required because my Java 8 is not 191 yet. And then I will basically add metadata in my Docker image saying that port 8080 is the port of interest. This is what my process will listen to. And then as an entry point, I will say that you need to run a java-jar on this application whenever you run this whenever you want to run it. Several things to note with this Docker file. Something like 1 or 2 years ago, there was the multi-stage build that was introduced. I'm not using it here, but basically with a multi-stage build, you would have 2 steps. A first step that would allow you to build the container. So you would need a JDK as build, and then you would basically compile. So you would run Maven, and at the end, the output would be a war, and then you would directly, from the build, add the war. I mean, that's fine either way. You can do that. You can use multi-stage build, or you can directly use your machine Maven to run the war. What is important at the end of the day is that you try to get lean images, because that's usually the thing that you want to have, is that you want the smallest image possible, with just basically your JVM and your application. And sometimes you also want some tools. So let's try this Docker file that seems it seems to be good enough. So basically, you would do docker build -t my image, and I will give this dot as my local context. So since Docker is not running on my machine, it's running in Docker for Mac, so it's inside the VM. It's sending all the context to my Docker daemon running on Docker for Mac. And then Docker for Mac will build this image and make it available so that if I do just after docker run -d in the background, I will bind 8080 to 8080 my image. So normally that should run, and if I do a docker logs -f b6b, yeah, the JVM should be starting just fine. So far, so good. Now, usually, when you start Dockerizing your Java application, you will probably want to have Maven run this for you. So, of course, if you're using a Maven build, you would want, to bind to the Maven lifecycle the containerization of your application. So there are several plugins that exist. So if you Google that on the internet, if you do Docker Maven plugin, for example. So that's basically the same for Gradle, right? So the first hit that you would get would be Spotify Docker Maven plugin. They've been here almost forever. I mean, I've been using it for super long. You know it, I guess, some of you. I guess. Anyway, it's pretty famous. And then the second hit would be Fabricate. They also have a Docker Maven plugin. And those two plugins, they exactly take the same approach in the sense that they will connect to my Docker daemon, and they will ask my Docker daemon, please build this, please build this container. And then, you know, they will just be done. So the bad thing with that is that whenever you're running your application, so be it on your laptop or in CI, for example, in Jenkins, that basically means that a Docker daemon needs to be listening, right? So you need to have a Docker daemon available. And remember that running a Docker daemon requires privileges, right? Pretty high privileges. So you cannot run it as a simple user. So that can be an issue, and usually most people have been, you know, walking around this saying, well, that's fine, I will have a special Jenkins slave with a Docker daemon running and available. But, you know, it kind of introduces security problems because whenever you have access to the Docker daemon, you can do bad things on the host, and so on and so forth. So some people decided to change that situation. Entering so the situation that when you get your Docker file, you send it to the Docker daemon, and then the Docker daemon build the image. And then you would also use the same Docker daemon to actually run your image, right? So when you think about it, is that the Docker daemon has two responsibilities. It can build and it can run. So once again, some people were not exactly happy with all those problems. Need to be run privileged, and it doesn't fulfill one goal, it fulfills two, so it kind of have too many responsibilities, and sometimes it's pretty hard to use and integrate with existing tools. So, entering the contenders. And all of them, if you look on the left side of this slide, so they address just one specific problem. Let's talk about the building problem. They are all daemonless, so they do not require a process to be running in the background. So that's cool. And basically, most of them, they really wanted to tackle this problem first. So for example, you've got IMG that was created by Jessie Fraser. She used to work for Docker Inc. And, you know, she was like, you know, discussing with colleagues and wondering how could I actually build Docker images from a place where I cannot access a Docker daemon. So that's a problem. I would need just, you know, a single process running non-privileged, and that would be it. And at that time, I think the problem was basically on Kubernetes, because inside Kubernetes pods, you cannot actually talk to the Docker daemon. So if you want to build on Kubernetes, well, you could not use Docker. So that solved a problem, but she was not the only one investigating this area. There's also Builder. They have their own CLI, just like the Docker CLI with different commands, but basically that is also able to build Docker images as well. Then you have Bazel, also from exists from Google, and this one is one of the other builders that does not support Dockerfile. And when you think about it, why would you need to stick to the Dockerfile to build the Docker image? Of course, we've grown pretty used to creating a Dockerfile, right? This is the first thing that I did when I decided to create a container for my image. But what if you didn't have to work with the Dockerfile, right? So maybe, you know, those builders can take information about volumes, about expose ports from image and so on, differently than using the Dockerfile format. And then there are build packs. So build pack is pretty interesting because it, I think it was 3 weeks ago, it got under the umbrella of the Cloud Native Computing Foundation. So I will talk briefly about it. It's basically the umbrella that is encompassing Kubernetes. So it's really getting official. And build pack, you probably already used it indirectly. Using Heroku or Cloud Foundry. You know, they got some tooling that detects your build. So for example, if you've got a pom.xml, it will know, oh, okay, I need to run Maven, and then I need to build the image. So basically, those build packs, and there is, well, I'm talking of the plural because there's also a draft from Microsoft Azure. They're basically trying to detect what is the build to run, what is the tool, and when they understand something, so if they see a build.gradle or pom.xml, they will know that they will need to build it, and then they will create the image automatically. They are still pretty young. Well, at least for build pack, I've tried it, and basically it still requires the Docker daemon to be running, but the goal is that it should run without the Docker daemon. I will focus for my next demo on Jib, and Jib is really interesting. So there was also a talk yesterday about it with its creators, and actually I can see them in the room. Hello. And Jib is really changing the game in the sense that it's running natively in Java. So from your Java build, using Maven or Gradle, it will know how to build a Docker image without a daemon running in the background. So let's have a look at this. One of the first things that you could do when you're running with Jib is that, yeah, let's do with this. It can be pretty fast, actually, to try it out. So this is something pretty nice to try. OK, wait. So you can directly add it. So even if you didn't add it to your pom.xml, you can just invoke Jib this way, So it's a standard Maven plugin. So you would just say to your current pom.xml, even if you don't have anything for containers. And you know what? I can even get rid of my Docker file to show you that it's not using it at all. Bye-bye Docker file, because remember, Jib is not using it anyway. So Jib, if I run it like this, normally it should be able to, to figure things out and to find, it should be able to create my image. And let's have a close look at what it's going to do, because it's a bit different than from the other containers, from the Spotify Maven plugin and the Fabricate Maven plugin as well. So as you can see, by default, it's going to get a base image that is named distroless Java. What is distroless? It's also an effort from the Google people, and they're trying to do with distroless base images that only embed the minimum things to run your container. So basically, in distroless, you wouldn't have a shell, but you would have a JVM and, for example, libc to be able to run JVM specific application. So what it means is that if you want to debug it, right, if you want to run a shell, well, that's not going to work. But at least the image is super lean. Then there are 4 pieces of information that are really interesting in this build, is that Jib apparently decided not to take the Uber jar from Spring and then put the Uber jar directly to /, for example, just like I did with my Docker file. No, Jib is interesting in the sense that it will build 4 different layers for each things of interest for my build, such as dependencies layer. So they're going to be on my jars, on my dependencies will be on this Docker layer. Then a resources layer with all the JSP, JavaScript, and CSS, for example. Then classes layer, they are going to be directly my classes. And also an extra files layer to embed something like an entry point. And then it's setting the entry point as a java-cp, so it cannot use the java-jar, right, because it's directly using the classes. And of course, it's going to set the class path with my resources, my classes, and my libs. And then it has detected that the main class is demo app. So there's one interesting thing is that I asked Jib to do a Docker build here in this example. So it means that Jib has been connecting to my Docker daemon to produce this build. So the cool thing when I do this is that I think, yeah, it has created demo 100 snapshot, but it has still been using my my Docker daemon running locally. But still, if I do a Docker history on this image, let's have a look at how it was built. So the 3 first layers They are the basal build for distroless Java, probably. And then the 4 other layers are exactly the ones that I just described, right? The big one are the dependencies, then we have some JavaScript resources, and then probably my Java classes, and also an additional entry point. So far, so good. Now, if I were to run this image, so I would just run it exactly the same when you think about it. It's not going to be my image, it's going to be demo 1.0 snapshot. The difference is that probably, if I do 2FF, so that's working fine. That seems to be working exactly the same. Now, if I want to do an exec, for example, as I told you, there's no shell because it's distroless by default. So if I do this, it's going to say, oh, what are you talking about? There's no shell, right? Sorry, shell doesn't exist because it's been using this distro by default. But you can provide a configuration to your Jib Maven plugin. So here in this configuration, I am instructing my build that I want to use OpenJDK 8 Jerry as my base image. I want to publish it directly. I want to use this image name, and this image name, as you can notice, it's using my username on Docker Hub, so probably that Jib will understand that it also needs to push it to Docker Hub. And then I can specify my own entry point, and I can expose a port, and I can even give some environment variables. So as you can see, it's pretty funny the way that, the Jib people they have been re-implementing kind of the Dockerfile, but, in a more Java-friendly way. So if I build this one, so I will probably, come on. The way I'm going to build it now is just going to be by Jib build. But before doing that, I'm going to kill my Docker daemon to show you that if you're running in a Jenkins slave without Docker on your laptop, you don't have maybe to install Docker on your machine, then if you do Jib build, it will not use the Docker daemon. It will really, by itself, build the image and publish it. So let's have a look. OK, there we go. OK, so I got, the image was tagged as prod. OK, this is a bit weird. I should have tagged it dev. Sorry, I'm going to redo it. Anyway, what I wanted to show you is that once it's built, you can go to play with Docker, for example, and you can test it out directly, right? It should work fine. So here, play with Docker is basically running Docker inside a shell on someone else's infrastructure. So you wouldn't log in, right? But since this image is public, that should work fine. So here I got full stack dev that was produced, and now we'll need to so now if I do a Docker run, I don't know if we can see much. Docker run -d -p 80. Well, I'm using actually play with Docker because I have killed my Docker daemon, so I still need to have a Docker daemon. And then I will use my image name. All right, so as you can see, it's going to put it, it's immediately available from a registry, so it's very cool if, if you basically want to test out your image outside your machine. That's also a very good option to directly push it to a registry. Okay, and then if I do docker logs -f E52, C, okay, I don't know how to read, C58. Apparently the application is starting, so it's going to take a while, and then yeah, could go to this port, and then it's going to be listening and so on. The application will be made available. I've talked about build containers. There are also some run containers with Cryo, for example, and RKT. They are also able to run Docker images and make containers out of it. Enough with containers. The talk is about Kubernetes, so let's get started with Kubernetes. Let's start with an introduction to Kubernetes, Kubernetes 101. Kubernetes, so it was released in 2014. It's Apache 2 license, so it's open source. It's written in Go. It was heavily inspired by Borg. That was an internal system to run containers inside Google. Now it is at its version 1.12, and they build a new release every 3 months on average. It's pretty important to keep that in mind because they also have a life cycle to deprecate things, so you need usually to pick up the latest releases. I mean, not immediately, but at least usually every year you should try to update. So yeah, currently it's 1.12, but most cloud providers and most people are still on 1.11 because 1.12 is super new. So it's not really recommended to use 1.12.0, but you would wait for 1.12.1 or 1.12.2. Kubernetes, so even if it was originally from a Google project, it's now under the umbrella of the Cloud Native Computing Foundation, and it's really the main project that this foundation is managing. There are Oracle, Intel, IBM, Pivotal, Red Hat, even my employer is part of this foundation. And it's bringing all those industry leaders under the same umbrella and trying to make cloud native tooling compatible, right? It's not the only project, as I told you. There is also another graduated project that is Prometheus for monitoring. Also, Helm is still incubating, Open Tracing, Containerd, CNI for networking, the build packs that I've talked about earlier on. So everything that relates to running workloads in the cloud and work nice with Kubernetes is usually a good candidate to be part of the CNCF. And you can go to cncf.io, and there is a nice landscape, and you can see all the tools that are part of it. So maybe I can give you just a quick look. For example, as I told you, there are only 2 graduated, Kubernetes and Prometheus, and then incubating. There are many projects that reach either tracing, network, packaging, volumes, and so on and so forth. Yeah, it's cncf.io. What about the Kubernetes architecture? So basically, well, we start from the user. From a user point of view, you will use a tool that is named kubectl or kubectl. It's basically a CLI to interact with Kubernetes. So the same way I was interacting with my Docker engine with Docker CLI, now I will be using kubectl. kubectl will talk to the Kubernetes master, so you need to have at least one, but you can have several for high availability of your cluster. And this Kubernetes master will provide to you an API server. So the kubectl commands will go to this API server and will, post objects and, well, basically will give orders to the API server. The API server will try to honor those requests thanks to the controller manager and the scheduler. Also worth of mentioning, you've got usually an etcd or an equivalent software, an equivalent key value store running inside the master to store configurations. Once the API server is receiving orders, once again, we'll try to honor them, and it will need some worker nodes to do that. In terms of, so here I've written here Kubernetes nodes. So those worker nodes, you once again need to have at least one to run some containers. And usually you would want to have several worker nodes because, of course, when you start deploying your application, you don't necessarily want to have all your processes running on the same machine, so you will try to spread the load across several Kubernetes nodes. Anyway, what are they made of, those Kubernetes nodes? They all run a kubelet that will allow them to communicate with the Kubernetes master. Also, they have a kube proxy, and the kube proxy is what is going to let them be accessible from outside. They also share together one common virtual network, so all their workloads, all their containers will be able to see each other, right? So it's also extensible, so this is why we said plugin network, because it could be flannel with net, so on and so forth. You could actually add your own network plugin, so that all the pods would see each other. The pod is the most compact, is the smallest thing that you would find in the Kubernetes world. And the pod is basically, it's a bit different than a container because a pod can actually run several containers. So inside the pod, yeah, you would be able to define several containers, and all those containers, they would see the same thing. So they would share the same host name, volumes, and so on. So you probably recognize that they are sharing the same namespace inside a given pod. And why did the Kubernetes project maintainers decided to do that instead of, like in the Docker world, you just have, the smallest form is a container. Why did they decide to go with something larger than this? Is to basically allow people to ship, for example, a sidecar container that would help the main container with loading some data, for example. It would grab some data and then prepare it so that the other container would start properly. So there are many tooling, actually, in the Kubernetes ecosystem that are currently using this feature, injecting their own sidecar containers to, for example, grab traffic, handle traffic, do special things with traffic, and observing what's going on inside the pod. So it's really popular now. Even if you, as a Java developer, probably you won't want to use this at first, but you will see it with other tools. Usually, you don't deploy a pod by itself. You would use a higher level concept. Let's take the example of the replica set. A replica set is defining how many pods you will require to run. So in a replica set, you can define the number of replicas. Here in this example, I've set 3 replicas, and I said that those replicas should match something with tier TMC. And this is why in a pod definition, you can actually put some metadata, some labels on it, so that those pods could be matched by high-level concept. But once again, you would not deploy replica set. You would deploy deployment. So deployment is one of the most common objects to run your workloads. And a deployment is like a replica set, except that it can do rollout and upgrades of some definition. So this is more convenient, actually, to have a deployment because you can roll out new versions of your pod, for example, and also do rollbacks. There are many other objects worth of mention. The jobs. What is a job? Well, as you would expect, that would run a pod, maybe just once or maybe periodically, and the job would try to rerun it. Would try to rerun this pod until it gets completed successfully, right? So very convenient, for example, if you want to configure your software, just a one-off job could do that, or maybe take a snapshot of some state. Job would be the right thing to do. Then you got stateful sets, pretty modern. They were introduced like maybe a year ago, I think. And they're very similar to deployments, except that they will keep a stable naming for all your pods. So when you run a deployment and you got 3 replicas, for example, the pods will have random names. With stateful set, they're going to be pod name -0, pod name -1, and so on and so forth. So they've got a stable naming, and also they have stable volume mounting. So if, for example, pod-1 died, when it's going to be rescheduled, it will try to reattach the volume that was used to be bound with pod-1. So it's stable naming, stable volume mounting. Usually interesting for stateful workloads, basically, such as a database. And then daemon sets. You wouldn't run daemon sets, probably not. But one good example is the kube proxy. You remember the kube proxy is working on each worker node. So basically, a daemon set is a set of pods, and you will have one instance of a pod on each worker node. So it's to make sure, for example, that all your worker nodes are going to run the same pod, etc. There are many others. Now that you know how to deploy your Java application in Kubernetes, now you would want to make it available, right? So you would want to expose it. To do that, you would define a service. By default, it's cluster IP, so it's the most common, and the cluster IP service is really a type of service that, well, expose your workload on a cluster internal IP, so that your workload would be available from within your Kubernetes cluster, but not from outside the Kubernetes cluster. Then you've got the node port, and the node port will expose your service, so it will bind a port on each worker node, and so that each worker node will, for example, if it decides to bind port 30,000, then on each worker node port 30,000, you will be able to access your application. This is the default usually with, well, this is usually useful with Minikube, for example. Then load balancer. A load balancer is the most common type of service. This is how you would make your workload available to the outside world, because it exposes the service externally. And when you deploy, for example, using a cloud provider, then probably when the Kubernetes cluster will see that you have required a load balancer, it will try to grab an external IP, and then once the external IP is fetched, it will be, probably correctly deployed. So, for example, here I got a little schema here, and I have defined a service of type load balancer on port 80, and it's matching the tier frontend label. So when it's going to receive traffic, so probably thanks to an external IP address, it will redirect this traffic across the several pods that have the label tier frontend, for example. Okay. Last slide about Kubernetes 101, the volumes. And they're pretty interesting because I know that when I started with Kubernetes, I was really glad to learn about ConfigMaps. I know that since then, Docker, they've got something similar now, but at that time, it was 2 or 3 years ago, they didn't. Anyways, let's start with the basic, the volume. So as you would expect, you can mount several types of volumes for your pods. And you could, well, here in this example, I got 2 volumes. I got one named, I have a config map, and I also have a volume with host path. Host path, as you would imagine, it's mounting the worker node file system. So that may sound good, but the problem is that when you're usually deploying containers to Kubernetes, you don't exactly know where those pods will be running, on which worker node, right? So if you try binding the worker node own file system, then what if your pod dies? And if it's rescheduled on another worker node, right? It will not bind the same file system again. So it can work, but you need, to use labeling and put some constraints on your deployment. The most popular options today are network-based file system, so that each pod can actually mount this file system. So of course you would start with NFS, why not? You could definitely use NFS, but also if you're running in a cloud provider, you will see that most cloud providers, if not all, they've got their own default storage class. And for example, if you're running on AWS will give you by default EBS volumes. So your pod, your Kubernetes pod would claim a volume, and then the Kubernetes cluster would think, oh, okay, so this pod wants a volume named, volume name like this, and by default, I know that I can start a new EBS volume. So that this is how it would work on AWS, but Google Cloud and Azure, they also have their own specific implementation of default storage class. Then, back to the config maps and secrets. Well, secrets are the same, except that things are hidden. The cool thing with a config map is that you can provide some configuration, and this configuration will be available throughout your Kubernetes cluster. So if you don't exactly know where your pod is going to be running, you know one thing for sure is that your config map will be available from anywhere. So this is really cool to put your XML files or JSON files, well, whatever the configuration you're using for your software, you put it inside the config map, it's going to be mountable for sure. So that's really reliable and very good. And if you remember in the previous diagram, with the etcd key value store on the master, well, this is what is going to hold the config maps actually. So when you know what Kubernetes is and you're ready, if you're ready to deploy, you of course would need to deploy it somewhere, right, to make something out of your application. For sure, cloud providers, they all embrace Kubernetes. So Google Cloud with GKE, Microsoft Azure with AKS, Amazon. You used to need to run kops. That was kind of a tooling around AWS to allow you to create Kubernetes cluster easily. But now they've got their own offering in stable. Well, no, it's an official release now. It's named EKS. Oracle Cloud has also its own offering, OKE, and then you get several others. I am independent. I'm not working for any of them, but still, I wouldn't be able really to compare them with each other. Maybe the choice that you would make for a given cloud provider would be probably about cost and affinity with a given provider. But anyways, the thing that I can tell you about those cloud providers is that they are all official Kubernetes provider, meaning that they really respect everything Kubernetes. There is no surprises when you switch from one to the other usually. You also have some playgrounds deployment. So just like Play with Docker that I've been using before, you've got Katacoda and Play with Kubernetes, pretty cool. You just start, or you just go to a website and then you are shelled in a Kubernetes environment. So it's pretty cool to test it out. And yesterday I've seen a tweet from the guy, I don't remember his name, Marcos Niels, yeah. So the guys behind Play with Kubernetes and Play with Docker, he just upgraded Play with Kubernetes to 1.11.3, so that's pretty cool. That's really updated, so I would really strongly advise you to have a look at this. Then, on-premise, if you want to install Kubernetes on your machine, on your infra, that's possible as well. There is the hardware, and the hardware is a set of instructions on how to set up all the components for the master nodes and for the worker nodes. It's called the hardware because it's a bit complicated and, it's definitely complicated to set up, but at least you've got another tool that is named kubeadm that makes things much simpler to do. And actually, kubeadm is being used by Minikube itself. Also, I have not mentioned it, but I know that Google Cloud as well with GKE, they have a project to have GKE run on premise. I don't know if it's available yet. I think so, probably. But that would be another option. And of course, I haven't mentioned OpenShift as well. And you've got some other vendors that would be happy to install Kubernetes on your premise. For local testing, Minikube, Minishift, and they're basically going to run a VM on your laptop and using VirtualBox, for example. And even Docker for Mac is an option. I'm going to talk a bit about it after. So now let's take the demo app to Kubernetes. This time, we'll go with a slightly more ambitious deployment, not just one container that is by itself. We'll try to have this demo app, so this monolith, talk to a real MySQL database. And it will also use, for caching, a Terracotta server, a high highly available Terracotta server, because as you can see, there are 2 instances. So that will be for distributed caching. And let's have a look. How would we do this? So we would go back to your IDE. Yeah, I have. Okay, great. So the cool thing that you can do actually, if I do a new file with IntelliJ, I think if I call it deployment.yaml, there is something like KDEP, Kubernetes deployment, press enter, ta-da, it's providing everything. The first time I saw that IntelliJ they had a plugin for this, I was super happy. Anyway, I would call it full stack. This is the name of the demo app. And as you can see, it's pretty funny because it's actually completing everything, all the boilerplate stuff for matching the different labels, right? So when you're creating a deployment, of course, you would need to match certain pods. So this is why, it's going to add all the required metadata so that everything will match properly. Once you've named it, and then you would give the image name. So in my case, that was my Docker Hub ID / full stack. And then probably I could add a tag. And now it's happy. And then the second thing I would do to be able to use my deployment, I would probably add a service. And one cool thing that you can do with YAML files is that you can have several object definition in the same file if you separate them with --. And then I would use probably K service. No? No, there's no more completion. Well, without completion, I'm going to be lost. I can tell you that. There's no completion. So let's skip to the part where I show you the one that I prepared already. And okay, and let's have a look at here. So this one is a bit more complete. So it's the same thing. It's a deployment. That's fine. Exactly the same name, full stack. I've changed the image pull policy to have it pull it always. Let's choose the right. Come on. Okay, let's choose this tag. Also, I'm going to provide it with some environment variables, mainly so that it can connect to MySQL database, and also the highly available Terracotta server as well. I could have set some resources constraint to make sure that it's running on proper nodes, but I didn't do that for the demo. Of course, you need to define an interesting port, 8080, and then you can also set readiness and liveness probe. Readiness probe means that Kubernetes won't consider this pod ready until this HTTP GET returns something successful, right? So something like 200 or something. And then once the readiness probe is passing, then regularly Kubernetes will run the liveness probe if it is defined, and same thing, it will ping this given servlet just to make sure that it's running properly. And the day that this servlet is not responding something like 200, then probably Kubernetes will consider it not working, and it will kill the pod and reschedule one. So back to service, the service that I was not, that I didn't want to do by hand, and there it is. This service is of load balancer type, but basically means that whatever Kubernetes cluster I'm going to use, it will need to make it available externally, so it will need to grab an IP address, for example. So let's have a look, and I'll talk more about those Prometheus metrics, but just notice for now that I have added some metadata for something else, and we'll see that in the last part of this presentation. So, yeah, one thing also worth mentioning is that I'm also going to deploy MySQL, and MySQL is a deployment here in this example with MySQL database setup and also with a service. But the service, of course, is not externally available. It's just a cluster IP by default, so that it's going to be reachable only by my web application, for example. Same thing for the Terracotta server. Instead, I've used a stateful set this time, and this stateful set also has a service linked to it, so that my Terracotta server will be available from outside. So let's deploy this to Kubernetes. Yeah, we're all set, I think. The first thing that you need to do is that you need to configure kubectl to use the right context, right? As you can see here, I've got 6 contexts available on my laptop. And, well, so far, I know that this one is on Azure, this one is on Oracle Cloud, this is Docker for Desktop, this is Minikube, this is on, when I'm working, this is only available through a VPN connection. It's deployed on my employer infrastructure, so we need a VPN to access it. It's an on-premise cluster, actually, and this one is obviously running on JK. So I'm going to use, I think for this demo, I scheduled to use the, well, I'm not sure what really matters anyway. So let's use this one. Then I have running in the background something that is named kubectl get all. So it's a watch, and every second is going to refresh the content of it. So as you can see, my localhost IP is this Oracle World name, actually. Well, my localhost name is that thing. And it's telling me that kubectl has access to this Kubernetes cluster, and that seems to be healthy. So let's go and deploy. It's pretty easy. You do kubectl apply, and then you send directly all the files that were in this folder. So as you remember, I had 3 long YAML files defining services and deployments and stateful sets and so on and so forth. And now Kubernetes has been instructed to run them all. As you can see, the interesting thing with this service, with this load balancer type service, is that it's waiting for an external IP to be available. So that should take almost a minute. And meanwhile, anyways, I've got some deployments that, well, some pods that are not ready. For example, my full stack pod is not ready yet. So I got my Terracotta server running, my MySQL database running as well. And well, there you go. I got a public IP. And whenever, yeah, now that my demo app is running, I should get, if I reach this IP, that should work fine, probably. Yeah, my application is running. And as you can see in this application, I got a banner, and this banner is displaying the host name of the container, right? So if you see it's C7, C something, yeah, C7, C something. Okay, so everything seems to be working properly. If I log into the app, I'll be able to check that the app successfully connected to the different dependencies, such as, you know, it's using this URL for the Terracotta server, and also for MySQL, that should use something like, yeah, full stack-MySQL, that is the name. So yeah, all in all, it's that's a successful deployment. But once again, we are working for an industry where people are never satisfied. So some people complained about this and said, well, that's so nice, Anthony, you know, well, they didn't talk to me, but anyways, imagine that. You see this, and then there's something that you could be angry at is those large YAML files, 100 lines for Terracotta. Then for MySQL, well, 40 lines of YAML. And then for the web app, 80 lines of YAML. That's a lot of YAML. There is a YAML fatigue everywhere now. So people, they want to try to get away from it because they're not so excited about this. So some people raise this problem, and some other people try to find a solution. And one of the solutions is Helm. Helm is not, once again, it's a tool that is not completely, well, it's not graduated yet, but still it's part of the CNCF, and I think it's, well, it's not graduated. This is what I meant to say. It's incubating. So what I mean to say is that Helm is not by default installed on your Kubernetes cluster. Although I have seen some cloud provider that allows you a little checkbox to install Helm by default. That was maybe Oracle Cloud, I think. Anyways, Helm, super convenient because it's going to treat your deployment files as packages, right? Just like APT or Yum, but this time for Kubernetes. So in a Helm chart, you would actually define your own deployments as well as your dependencies, right? And once you have defined all of this, you can package this into a tarball, and then you can share this tarball with a Helm repository. By default, it's the chart museum. It's for open source stuff. But you can also host your own Helm repository on your premise, for example, with Artifactory, and there are also some cloud providers that allow you to have private repositories. But it's not only about deployment and packaging Helm. There's also a very nice feature that is templatization, because believe it or not, in all the YAML files that I've shown to you earlier on, there's no way to do some string replacement. So I can tell you that at first I was confused with that. I was like, oh, damn, this is crazy because I cannot replace my image name, or I cannot replace my tag, or I cannot replace anything. I need to write another definition, or I could put it in Git, right? But still, that's kind of weird that common things could not be replaced. Hopefully, yeah, at first I was using sed. Yeah, you can use sed if you want to, you can use sed, or you can use Helm, and Helm will templatize some parts. So for example, here in this example, you can replace all the values. And I know that there is another effort to do that simple. It's named Customize. I think it's also from Google. And Customize is, you could apply a diff to a given YAML file. So take the YAML definition file, take the diff, and it's going to merge them, to make them match. That's another approach. But Helm, anyway, is pretty mainstream, so this is what I wanted to introduce it in this presentation, because many people are expecting Helm now, and well, they're kind of right, because it's pretty easy to use. So Helm, I would go directly to the Helm chart that I created, but it's pretty easy to do. You just do Helm init, Helm create, and then you would end up with a template folder with some deployments. So here, you would probably recognize the deployment that I created for my web application earlier on, except that everything is kind of templatized. So you would wonder, where do you define the default values? Well, you've got a value.yaml, and in value.yaml, you can give, for example, the default repository tag, pull policy, and also you could even configure some values for your dependencies, right? So if you look at my requirements, I've got two dependencies, one for my SQL Helm chart and another for the Terracotta Helm chart, and I can still configure them from my web application. Let's try this actually. So we're going to switch cluster this time. I'm going to use another context. I'm going to use this one. What about kubectl get all? Okay, yeah, so this one is pretty empty. And I think I already have Helm. So if I do Helm ls, well, I have Helm. One thing that I didn't say is that with Helm, you've got two parts, right? You've got the Helm CLI, and you've got the server-side part that is named Tyler. So if I do Helm ls and it's not saying anything wrong, it means that the Tyler parts of the server-side part is already deployed to this cluster. By the way, in the next version of Helm, there won't be any more Tyler, there won't be any more server-side part of Helm. It will just run inside your client. So that's going to be even easier to deploy. Anyway, if I do Helm, I would, if I want to install my application using Helm, I would do that. So what am I doing here? So what is this command line doing? Helm install, I'm going to give it a name. So when you deploy a Helm chart, you create a Helm release. This is, the naming. Then I set some API keys, and yeah, I'm basically overriding, well, for example, those two defaults, I am overriding them. And then I'm saying that I want to deploy the Helm chart found under full stack folder, but I think I'm not in the right folder anyway, so I need to go there. Yes. So the cool thing with Helm is that usually at the end, when you deploy a Helm chart, it's usually going to give you a few information by default. It's going to say, oh, well, look, now you can access your service from this place, and so on and so forth. So if you look at kubectl get-all, you will see that that everything is working fine, that Helm is definitely trying to execute everything that was defined as Helm chart, right? It's very similar, right? It's just manifest files that are being generated using the template. So hopefully enough, an external IP will be issued, and yeah, everything should work great. Okay, let's move on to developer tools. As I said earlier on, you add complexity, so you know on top of your Java application, containerization, orchestration, how can you still be efficient at your work, right? Developing stuff. So you've got what I call the classic tooling, the IDE plugins such as, well, I'm using IntelliJ, and there is also the same thing for Eclipse, Visual Studio Code. I mean, all the tools kind of have plugins to support Docker files, Kubernetes, and even now Helm, IntelliJ, the next version that's going to be released, will allow you to autocomplete Helm charts. So that's going to be pretty cool. Also, you have tooling to deploy directly to Docker, for example, from your IDE. So, run on Docker, and can be fun. Also, you've got your build tools, such as Maven and Grafana. So that used to be the Maven Docker plugin from Spotify and Fabricate. But as I told you, Jib has my preference for now, because it's totally integrated in Java, Daemonless, so that's super cool. Docker for Mac and Docker for Windows, they also come with Kubernetes support, actually. So it had been out for, well, it was announced a year ago at DockerCon 2017, and it's been available in stable releases for 6 months already. So yeah, with Docker for Mac, Docker for Windows, you can have directly a Kubernetes cluster, but you could also use Minikube. And to be honest, I would advise you to stick to Minikube, because most Kubernetes tooling is usually tested with Minikube. I mean, whatever new tool, cool tool that you will discover with Kubernetes, they're always tested with at least one cloud provider and Minikube. So this is why, sticking to Minikube can be a nice thing, because some tools do special detection of Minikube. Oh, it's Minikube, I should do this and that. Anyway, so I'm not sure if that works that well for Docker for Mac Kubernetes. Kubernetes tooling. What about it? Skaffold. So Skaffold, there was a very interesting presentation from the Jib guys yesterday. And with Skaffold, basically, you magically auto-redeploys on change. So the Skaffold goal is to tackle the repetitiveness of all the steps that you have to do whenever you update your code, right? So whenever you update your code or your deployment definition, you usually need to build your application, then put it inside a Docker image, then push this Docker image to a registry, and then you finally need to redeploy it, right, to see what are the changes. So Skaffold, the cool thing with it is that whenever you're going to do a change, a file change, well, so resource file change, so it can be a class change or deployment change, or a deployment definition change, or a resource, such as a JavaScript, it will detect that and will say, okay, I need to run the build. And with Skaffold, so it's still a pretty young project, but they already have several integrations for building. So you used to use Skaffold with, so Skaffold initially was working with a Docker build, but now it also integrates well with Jib, because we have the same people working on it, so that kind of makes sense. Let's have a look at a Skaffold deployment file, what it looks like. So it looks like some regular Kubernetes YAML file, except that if you look at it, they've got their own API version and kind. I'm saying this because I'm just planting the seed right now for the last chapter. They are basically defining their custom resource definition for their tool. So Skaffold. When you look at a Skaffold configuration, you would give it an image name. And be careful not to do like how I did recently, to not put a tag. Do not put a tag because Skaffold will take care of tagging for you. Whenever you're going to redeploy, it's going to update the tag. It has several strategies to tag, so do not put a tag because it's going to take care of it. Then you've got a given context. So that's basically going to be the context of the build. And as part of the build, I will want to use Gib Maven, and I will apply some profiles. So basically, they are Maven profiles to this Gib Maven build. So as you can see, I want the prod profile and skip test. Interestingly enough, also, you've got a deploy section where you can tell Gib, whenever you redeploy, use those Kubernetes manifests, right? And those are the same that I deployed initially before Helm. So we're going to do something interesting. We'll go back to my previous cluster. And that was context something. So if you remember, that one was deployed, with plain Kubernetes manifest files. And here I've got, I have Skaffold that will be listening to those manifests, actually, that I've been using. Before I can use Skaffold, I will change my image name, and I will remove the tag, because once again, Skaffold will not understand if there is already a tag. It's going to say, I'm going to skip it because you've got a tag. So I'm removing the tag, and normally, if I ask Skaffold to start, watching my changes, normally it should be pretty happy. Okay, so let's do Skaffold dev. There are several other modes, such as Skaffold run and Skaffold something else, I don't remember, for CI, for example, or for initial deployment. But the dev is really, I'm focusing right now on developer tools, and it's really for the developer tools. So let's do a Skaffold dev, and let's see if Skaffold is picking up my stuff. So apparently it has discovered that, yes, we are using Gib Maven plugin, and the first thing that it wants to do is that, I will run Gib, and I will tag your image. So I'm going to run Gib, and I will publish this new image immediately. Once it has done this, it will want to deploy it, right? And as you can see, Gib has noticed that everything was already deployed, except that the full stack needs to be reconfigured, right? Because this is the deployment of my web application, and now Gib is taking care of it. It says, okay, well, it's configured, and basically, I am running your stuff. I'm running your web app from now on. I will be responsible for that. And soon enough, Gib will redirect, will pipe the output, the system out of my new pod. So that should be pretty soon. If, meanwhile, you go to kubectl, you will see that Kubernetes is actually killing my initial, it's not killing it yet, but it will also, see now, it's terminating my previous pod that was deployed first, and now it's running this new pod that supposedly has been ordered by Skaffold. Yeah, so as you can see, Skaffold is happy because it's redirecting me the system out. So if I go back to my application is still running, right, on the same service, because you remember that the service, right, is just kind of a router. It just knows that the previous pod is dead, so now it's going to redirect everything to the new Skaffold pod, for example. So if I go back to home, and what if I was, for example, what if I decided to change something in my code? Let's do, let's do a change in my application, and that would be, yeah, there. Let's say that whenever I'm done deploying, I'm going to log something else. I know it's a lame example. Oh. And normally, Skaffold's gonna notice it. So, oh, damn, something has changed. I need to rebuild everything. I'm going to call gmaven plugin. I'm running the Maven build, and then that doesn't work. Wow. Of course, it's the first time I see this, so that's pretty interesting. It does not exist. 333. Oh, yeah. Yeah, that's funny. It didn't get, okay, so, now, that's not Skaffold fault, it's basically my fault. Yeah, it's just importing a class that wasn't available. So let's see if Skaffold would be nice enough to try again, to trust me again that, well, you know, it's pretty nice, you know, it's, you know, it has still faith in my code, you know, it's gonna try again. So hopefully this time, yeah, so this time it's gonna be successful. And yeah, it's gonna rerun it and probably, all right, so now it has been built and it won't try to push it again. Yes, so now if I go back to kubectl watch, you'll probably see that, you know, it's trying to create a new one. And probably when the new one is up and running, it will decide to kill the other pod. You know. And yeah. Okay, there we go, and as you can see, repushed. Yay! It has deployed my my latest pod, so it's ending with ZC something. So probably if I reload this page, I will see everything being served by ZC something. Yeah, ZC something is the host. Okay, cool. Everybody cool with Skaffold? So this is basically what it does. It watches for changes, redeploy everything, super easy to do. So you're almost back to a normal Java workflow with this thing. So that's pretty nice. Let's kill Skaffold and let's move on to another tool that I think is interesting and that kind of try to tackle another problem, or at least another approach with development process. It's Telepresence. Telepresence is already under the umbrella of the CNCF. Yes, it is. I'm just going to, well, anyway, we'll see that later. But yeah, I think it's already part of the CNCF. So Telepresence goal is to allow local processes to be available in a remote Kubernetes cluster. So say you have deployed, so here, in our example, we've got the full stack web app, we've got MySQL, Terracotta servers running. Say if you want to run your web app, but you want to run your local version, the process that is running on your machine. So you will start it on your machine, and then Telepresence will create a shim pod, basically. So that will be just kind of just a shell, and all the calls to this pod from the other, well, you know, for example, from the request coming from the service, or any other pods trying to interact with this pod, all the calls will be redirected to my local process. And I think it's better with an example. So let's start with, I'm going to switch context once again for this example, and I will use the Azure. What about you, kubectl? Yeah. So here I still have my deployment from Helm. It's back again. And the first thing that you need to do with Telepresence is actually call the help, because it's pretty well done, actually. They got a nice help, and they give you several examples. So let's try with the most basic example. Like here they're saying you can run curl. And when you run curl, it will be a local process on your machine, so local curl on your machine, but it will see things inside your cluster that are not exposed via services, right? Because you will be at the heart of your Kubernetes cluster. Except I'm going to run curl, I will do something like even better than curl, bash, right? So if I do run bash, that will be pretty cool. Yeah, it was weird. So, first thing that you need to notice is that it's asking for sudo password, because Telepresence, and this is one of the drawbacks of Telepresence, it needs a lot of accesses. When I'm saying this is that the first time I tried Telepresence, I was connected to my employer VPN, and that's not going to work with Telepresence, because Telepresence is actually deploying its own VPN to allow two-way proxying between your machine and the cluster. So if you're working on a VPN, forget about it. That's not going to work. And there's also some limitations with regard to volume mounting, because Telepresence could also allow a local process to mount a remote volume. But if you're running on a Mac, I think it's not working. So anyways, there are many limitations. And I think that the Telepresence team is pretty aware of those limitations, because they got a lot of documentation around what's working and what's not working according to your environment. But anyway, if, say, you're working on Linux, on a Linux laptop, and you're not connected to a VPN, you would have full access to Telepresence normally. OK, so let's have a look at my bash session on Telepresence. And if I do, let's say, curl, well, first, is my bash session running on my machine? So if I do /users, it's a Mac normally. Yeah, so this bash session is definitely running on my machine. But the cool thing now is that if I do curl on full stack, that is the name of the service for my web application, as you can see, it returns, right? So it definitely can see it. And it's basically seeing everything inside the Kubernetes cluster. And look, this bash session was even populated with the environment variables that are available throughout my Kubernetes cluster, such as the environment variables for my services and for some of my deployments. So I'm really inside my cluster, even if the local is even if the process is running locally. So it's super cool. Now, running bash, it's funny, and to be honest, that can be pretty cool to be able to debug things out. But the killer feature of Telepresence, and the really funny thing about it, is swapping deployment, right? So if, for example, I do, wait for me, just one sec. If I do swap deployment, I can target a specific existing deployment on my machine. So here, for example, I have a full stack deployment, and I can tell Telepresence, just grab this deployment, and then you're going to run locally this Java process. So that's my application running locally, as you can see. And I want you to kill the existing pods of this deployment and replace it with my local process. So Telepresence will create a shell pod, once again, to redirect everything to my local process. So let's have a look at it in action. So it seems to be happy for now. Oh no, unable to access jar file. Well, that's my fault, sorry. I was not in the right folder. Let's try again. And are you happy, Telepresence? We'll see that soon. Yeah, so see, it's starting the local process, right? So far, so good. Well, but now let's have a look at my Kubernetes cluster. You will see that there is there is a terminating pod that used to be the pod serving my content. And I guess that Telepresence is trying to replace it. So we'll see that soon. So yeah, now it's up and running. And now you see this thing. So this is the new pod that is responsible for my web application on my Kubernetes cluster. And if I go to this external IP, so if I go to the external IP of my Kubernetes cluster, normally the host name of the pod will be my local host name. And this is my local machine. My local machine is serving the content that is accessible via the Kubernetes cluster. So this is really crazy. Well, I mean, really crazy. This is really fun to do that. Of course, it's pretty. There is a nice mention on their website of a Telepresence team saying that do not do that with production. Do not run your local processes directly in production. But if you want, you could actually. That would be fun. But more seriously, though, I've been using Telepresence when the other day I was debugging a problem that was happening with my application only with a certain load. So it was a testing environment, and we needed to deploy 100 containers to start putting enough load on our web application to see the issue coming in. And the cool thing with Telepresence is that I was able to run in debug mode locally on my machine my application, and I would receive the load from all those containers. So I was at ease. I was with the comfort of my local process, with my IDE, with my debug mode and whatever, directly without redeploying, without creating an image or whatever. Just Telepresence just made it available, and thanks to Telepresence, I could benefit from a Kubernetes context with a huge load that I would not be able to run on my machine. So that was really useful for that. That's it for tooling. Now let's dive into the last part of this tutorial, integration with Kubernetes. So once that you know how to build your Docker images, you know how to run them, you know how to run Kubernetes, you know how to make your Kubernetes deployment available, and you also know now how to be efficient as a developer with several tools such as Skaffold and Telepresence. So you think you're good with Kubernetes, right? But you can still go a little bit further. You can start leveraging Kubernetes benefits for your application. Let's start with monitoring. Prometheus is the only other project with Kubernetes to be CNCF graduated, and so what is it? First, it's a monitoring system and time series database. So maybe you're already familiar with New Relic or Datadog and some other software as a service offering, but well, there are also on-premise monitoring tools. Prometheus is one of them, and it's highly popular in the Kubernetes world. So if you start, for example, deploying your Java applications on Kubernetes, probably you will find some other, it's not going to be the only process that you will want to monitor. You will probably want to monitor MySQL, Terracotta servers, and many others. And it would be nice if with just one dashboard, you would be able to see them all. And basically, if your Java application is providing integration with Prometheus, but certainly going to help. So Prometheus, by default, the way it works is that it will try to pull metrics from your application. So it's going to do some HTTP GET regularly on a given servlet. You don't have to do this way, but you can do the other way around when you can have a node that can push metrics. You can have a node exporter where you can push metrics to, and then this node exporter will make them available to Prometheus. I have a schema actually coming up. One thing that I would like to say is that it's super easy to integrate with Prometheus. It's not a huge effort, to be honest. If you already have some kind of metrics in place in your Java application, so for example, maybe you're already using drop wizard metrics, or you're using Micrometer, or any other tool, basically they provide Prometheus integration almost for free. Just drop a Maven dependency, and you should be good. If it's not the case, it's still pretty easy to register a monitoring registry and then add metrics to it. That's pretty simple. This is the architecture of Prometheus. The way it's working is, for example, so Prometheus is right there, and it will try to pull metrics. As you can see here, it will pull metrics to it will try to pull metrics from some pods. Of course, those pods, the question that you would ask is how can Prometheus be aware of such pods, right? Because pods in Kubernetes world, they come and go. And this is kind of a magic thing with Kubernetes and Prometheus is that if you put such metadata on your service, whenever you've got new pods running new pods available under that service, Prometheus will know, because Prometheus is watching for anything that is providing this information. So whenever your new pod is up and running, Prometheus will know about it and will start pulling metrics from it. So it's like magic, really. The first time you run this, it's pretty, it's pretty cool to see that you don't have to tell Prometheus. Prometheus will find out about you if you expose the right metadata. As I said earlier on, you could also have some node jobs exporter that would actually expect some metrics coming from you. So if you're more using the push model, you would push them to the exporter, and then those exporter will make the metrics available to Prometheus. Once Prometheus gathers your metrics, basically you would want to have a nice UI on top of it. So let's have a look at all of this. And yeah, let's get started with Prometheus. So I'm going to kill. Is it a good idea to kill Telepresence that could break my deployment? So let's stay on the safe side. And the best thing the best tool to deploy stuff on Kubernetes is definitely Helm. So let's do a Helm install. If I do stable/Prometheus, that should work fine. Oh yeah, wait, I would need to give it a name. But if I don't give it a name, it's gonna choose its own name, and usually they're really, really weird name. So name my prom. Whoa. Why is that case? Because on this cluster, I have airbag. That's interesting. On which cluster am I running? Okay, go away. And so let's have a look at my context. And I am on Anthony Demo, and Anthony Demo has airbag. What is airbag? Airbag is role-based access control. And for the demos, I scheduled, I had envisioned not to set up airbag because it's simpler like this. And apparently, Prometheus is requiring it. And that's weird, though. I thought I disabled it. Yeah, well, that's not going to change much, I guess. Yeah, of course. All right, so let's change context. I think that the other cluster didn't need airbag, so let's have a look. What's the one? Context something. What about you? Do you have interesting stuff? Oh no, everything is dead now. All right, so let's do the Helm dance. Let's first install. Let's take it back from the beginning, and let's install my Helm chart. Wait, I needed the special command with all the APIs key. Okay, that's fair enough. And I can, if it already exists, I can delete it, and then I'm going to rerun it. So I have nothing running, right? Yes, nothing is running. Let's deploy this. And then I hope, all right, so this is my full stack application with MySQL and Terracotta. And hopefully, I will be able to install Prometheus with Helm without setting up airbag. Okay, cool. Yay. So, as I told you, when you're running stuff with Helm, it's pretty convenient because it's usually telling you some information on how you can access the services that you have just deployed with Helm. So something that's going to be super interesting for me is the the Prometheus location. And okay, I got it clipped. And now I'm also going to deploy this time Grafana. And Grafana is a nice UI to show Prometheus metrics. Yeah, I will need to call it my graph, not the same name. Okay, well, persistence disabled. So as you can see now, there's a uber mess happening on my cluster. Everything is trying to run. So probably that it's a tough time for my cluster right now. It's separating everything at once, but it should handle it eventually. Okay. Okay. So let's go back to this to my web application. And as you could see, I don't know if you noticed, but I said that the Prometheus metrics servlet will be there. So let's make sure it's there, because if it's not going to work. So okay, cool. As you can see, this is what Prometheus servlet looks like. There are several information. There are some gauges, some counters, but keep changing and being incremented through the life cycle of your application. So normally, Prometheus should pick that up. So when we started Prometheus, they told us that we could actually access Prometheus using. All right, so let's have a look at how we can use Prometheus. Here we're talking about the alert manager, the push gateway. No, I would rather want to. All right, so here I'm going to do what they are. All right, come on. Get the Prometheus server Helm by running this command in a shell. So let's try to do this. Okay, and maybe in yet another shell. Okay, cool. So I got pod name, and then what did they tell me to do? They said, oh, you can do port forward. So if I do port forward, basically it will be port forwarded to my local machine on 1990. So let's have a look. Okay, fair enough. Okay, cool. So that looks like the Prometheus UI, and normally it should have some metrics such as JCache metrics. Yeah, as you can see, that's a good sign. That's a sign that it has at least once recovered those metrics. So if I do an execute on it, it will probably give me some value for this metric, right? So you can, basically do a quick test on it. And you can even graph it, actually. So what is the value? Yeah, as you can see, there is a value graphing. So basically, Prometheus has already started putting metrics for my application. That's cool. But as I told you, the best thing is to have a UI dedicated for that. So you would usually go with Grafana. And to have Grafana, let's kill this port forward. And instead, let's try to port forward Grafana. So Grafana is also nice enough to give me some instructions. Oh, wait, there's a password for Grafana. So let's first the password. I'm sure we're going to need it soon. Then probably they're giving me instructions to get the pod name. That didn't work. Okay, thank you, Grafana. But I can find the pod name right there. Okay. And if I do export, pod name equals. Okay, so I'm still in business. And now I can do default port forward on 3000. Are you happy? Yeah, that seems to be the case. So now let's have a look at Grafana. Admin, and my password is the one I just grabbed earlier on. And from Grafana, you would be able to add a data source, and the data source would be the, the Prometheus server. In my Kubernetes cluster context, I'll need to find its name. I think it's this one. Yeah. And then it's listening on port 80, I think, so I don't need to do much. Save and test. Data source added. No, HTTP error. Oh, yeah, it's because I know why. HTTP. Now it should be good, right? Yeah. It's funny, it's telling me it's added, but it's not. Oh, wait, it's maybe on 1990. I don't remember. Bah, I won't insist. But, oh, wait, no, it's because of a name. I'm so sorry. Yeah, I should read the fields, Well, you know, we're all users, we're all doing the same thing. Not reading stuff. So data sources should be added. Yeah, whoa, finally it's working, yay. And now from there you can create a new dashboard, and in your dashboard you can create a graph. And I guess in this graph you can add, in this graph, come on. Well, okay, I don't want to do this, but basically you can add some new points. Unless I'm confused, no data point, yeah, I want to add some. I think you can edit it, yeah. And from there you can start, pulling some metrics such as some JCache information, add query, and it's gonna graph them, right? It's going to start graphing them. So this is really common thing in the Kubernetes world, This is why I'm talking about it, is that once you get everything running, you want to play nice with Kubernetes and basically just try to share your metrics with Prometheus. That should normally be picked up by most of the tools. Now, this is the last topic I'm going to bring, but to be honest, this is the one I prefer. This is the one I am currently investigating for my employer, for the Terracotta server, open source version and also the enterprise version, because it's complicated to deploy a high available cluster, right? So as we have seen, either you go with several huge manifests, or even if you go with Helm, you still need to manage your workload at the end of the day. So if something is not working in your cluster, then you still need to have some manual intervention and try to understand what's going on and what's wrong. The same thing for configuration. For example, for the Terracotta server configuration, we still require the user to provide us with a huge config file. And in the Kubernetes world, that doesn't really work out, right? Because you wouldn't need to do such things. You would. I wish we could just provide the minimum information to run our Terracotta server, for example. Entering the world of operators, and Kubernetes operators are just done for that. So it's not an official word. Some people call them operators, or some others call them controllers, and they're really, really popular in the Kubernetes world. There are some couch-based operators, some MySQL, some PostgreSQL operators. And what is the goal of an operator is that it's here to simplify the development of your application. You just grab a very small YAML configuration saying, oh, I want 2 servers, I want that amount of memory to be available, I want that amount of disk space, and then the operator is going to take care of everything for you. Something like a year ago, I think CoreOS made some noise with bringing the CoreOS operator framework. And I was quite excited when I see that, and they were listing many operators for a lot of different open source software. So that was pretty cool. Except it was written in Go. So I mean, I won't bash Go or whatever, or their weird syntax or whatever. But still, I am attached to Java, and I was like, damn, isn't there a way to do this with Java? Why is it always Go Kubernetes, Go for Docker, Go for Helm or whatever? I mean, can't we do stuff in Kubernetes with Java? I found out that you can. So that's the cool thing. You can really write your own operator in Java. How does that work? Basically, you would use a Java SDK for Kubernetes, and currently there are 2 of them. So if you look at the bottom right of this slide, you will see I've got 2 different dependencies, 2 different Maven dependencies. One for io.fabricate Kubernetes client, and the other one is io.kubernetes client Java. So first question, which one would I choose? Well, Fabricate was there first, but io.kubernetes sounds like it's official, right? It sounds like it's official Kubernetes support. Now, if I'm using OpenShift, probably the Fabricate people, they would handle OpenShift, and well, this is correct, right? But if you're using pure Kubernetes, then you would ask yourself a question. The good news is that the API, they are both using the same builder API. I mean, it's almost exactly the same. They're using the same names, the same builders. Well, everything is is really, really similar or even the same. Why? Because those SDKs are basically generated, they have they have a SDK generator that connects to the API server and then generate all the objects, right? And thanks to that, well, since they're connecting to the same API server, well, they end up with the same classes. Well, at least this is my interpretation of it, and I was pretty happy to find out that whether I use one or the other, it's super easy. I just change my imports at the top of my class, and cool, I've switched. So at least that's one less problem to think about. Now, what can you do with operators? There are two ways to look at operators. So an operator is going to run inside your Kubernetes cluster, and if you look at the Terracotta operator that I started developing, the first way you can interpret that is that you would have the user, you will provide the user with a new CLI, right, with a Terracotta CLI. And this is what they've done. I know that the guy working on the PostgreSQL operator, they provided a new P-SQL-like CLI. And this CLI will only talk to the operator, and it's going to say, hey, just bring me a new PostgreSQL cluster. And then the operator will directly receive this call, and when it receives such a call, it will talk to the Kubernetes API server exactly like kubectl would do, and it will say, I need this deployment, this statement set, I need those config maps, I need all of that. And once it's ready, probably that your operator is going to return to the user, is going to say, yeah, that's good, your cluster is available at this location. Now, when I say that a Kubernetes operator is probably more interesting than a Helm chart, is that your operator could be smart enough. I mean, you could code in your operator that it could ping your own servers, maybe every day, to check for the latest version, right? And you could do running upgrade by itself. I mean, with an operator, sky is the limit, basically. You could really code all your infrastructure or all your business inside of the operator, right? So that they wouldn't need to have a DevOps running things, right? The operator would just do, well, would just manage and upgrade this deployment by itself. So that's pretty interesting what you can do, because the operator, once again, connect to the API server and can do whatever a human would do with kubectl. So this is one way of doing it, either with a CLI, so you provide a CLI to your user, so you create a new CLI probably through a REST API, or you can even provide a UI. And I've seen a presentation with the Postgre people, and this is what they did at first. But also another way to do it is to use custom resource definitions. And when you create a custom resource definition, basically you are instructing your Kubernetes cluster that, hey, there is a new namespace. There are some new objects that I want you to learn about. And when you will see some of those objects being deployed, call my operator, because my operator knows how to handle them. So basically, the user would do a kubectl apply on some YAML file. You know, you remember the Skaffold YAML file? You know, it had its own namespace. So basically, you would create a file very similar to that. So you apply. So you do kubectl apply on such a resource, and then you would then the Kubernetes API server would receive that and would know that the Terracotta operator is watching for these resources, so I should tell it that the user has tried to deploy some configuration for it. So this is what you can do with the Java SDK. You have a watch. And once you start watching that, you will be notified by Kubernetes. And then, of course, it's time to deploy the services, config map, deployments, and so on and so forth. I'm just saying here that there are two ways to deal with an operator, whether you interact with it directly via CLI or web UI, or you just leverage Kubernetes custom resource definitions. And most people are using right now custom resource definitions, because otherwise, when you think about it, there's going to be a multiplication of CLI across everything. So, well, it's not settled yet. I think in 2018, both approaches are, well, make sense. Let's have a little bit a look at the code for such an operator. And let's start right there. Here in my application, it's a Spring Boot application. And what I'm doing is that when the application is started, for example, I'm retrieving a Kubernetes client So it's a Java object, and from this Kubernetes client, I can start, for example, trying to create a namespace for my application, right? So maybe as a property, I want to have my deployment to be available in a given namespace. But the interesting part is really this one. When I want to create a cluster, I provide it with its own, with the own operator configuration. And I would say, well, give me a service builder, and then on the service builder, I will add everything. And if you look closely to the YAML that I had for the same service, you will see that they're really, really similar. I mean, you can put them side by side, and you will just find everything back, right? So we're doing a service, we're adding metadata with name, Terracotta, add labels, app, and it's going to take this value, and so on and so forth. So it's super easy when you think about it to just programmatically provide workloads to Kubernetes, right? Because it's as easy as, it's a bit boring, sometimes you just type everything like that. But at least, yeah, you can definitely provide such a service definition, and then a stateful set builder. Of course, you've got deployment builder, job builder, and whatever. You've got everything. And then, yeah, you can definitely start whatever you want on Kubernetes thanks to this SDK. Cool. Thank you. It's the end of this tutorial, but is it the end or just the beginning of your Kubernetes learning? Well, there are many things that I haven't talked about. I even just scratched the surface. What are RBAC, role-based access cluster? As you could see, I got bit by it during the presentation. It's because it used not to be mandatory, but now most cloud providers are enforcing role-based access control. It's a bit difficult. Well, it's not super difficult. You just need to assign some rights to your pods and then make proper groups and so on. That's not the end of the world, but well, you still need to learn about it, and because it's getting enforced more and more now by default. Service mesh such as Istio, they are all the rage in 2018. Everybody's talking about canary deployment. For example, if you've got 10 instances of the same pod, maybe you want to just send some traffic to one and the rest of the traffic to the 9 others. Maybe you want to have observability, traceability with Jaeger, for example. So there are many things that you can do with Kubernetes. Also, something I haven't talked about are ingress controllers. You've seen me using a load balancer service to provide an external IP. Well, load balancer, they're cool, but they do not support TLS. So, for example, you would need to provide an ingress controller to have, to handle TLS because it's not at the same, it's not operating at the same layer. But yeah, you would definitely to invest that, and then you would probably need to invest with integration with a certificate authority, such as, I don't remember the name. No, whatever, the free certificate authority on the internet. Anyways, what I mean to say is that we have many, many integrations that you can still do. This presentation will be available from Wednesday on the Oracle portal, so be sure to check again and try to get it, and also probably put it on SlideShare, so if there are some slides that you liked, you'll be able to get them. The demo app that I've shown to you with all the Skaffold, Kubernetes, Helm deployment files is on GitHub, and you'll be able to find it. If you enjoy me talking during 2 hours, you can still see me talking for 45 minutes this afternoon with my colleague Henri Tremblay from Software AG, and I will talk about caching and Terracotta server. Thank you all for attending this session. Bye-bye.